Okay, so let's start today's topic is transformations of parent functions. Okay, so to understand how to transform parent function, first you have to know what is parent functions. Okay, so basically it is the simplest form of the function. The simplest form of the function. Okay, now let's do some example for actually explaining what is parent function actually, right? So basically it can be a simple function as f of x equals x, and what you call it is a linear function. Okay, now we have another example for this. Parent function can be x squared, which is very basic, the simpler, right? You can say the simplest quadratic function, okay, is called as the parent function here. Sorry, it can be quadratic function. So these are the two examples which is explaining you what is parent function. Now move on, we're going to understand how to transform parent functions and what is actually transformation of parent functions. So okay, so actually you say whenever a function is transformed, okay, like it can be transformed in either you can translate this function, or either you can translate it, you can reflex it, you can stretch it, you can do any transformations, okay, on the parent function, right? So then that function is said to be transformed, okay, and is actually would be called as the transform function, right? So now understand, if you want the function to be transformed, you have to make changes in the parent function, okay? Either you rotate it, you reflect it, you translate it, you like shift it, you can do any of the transformation. These are all of these things transformations. Okay, now let's take an example of transform function. I'll give you an example. Transformation. Let's say there's a parent function which is a simple linear function, as I already mentioned at the top, f of x equal to x, right? Now if I say to transform this function, it can be either this way. I'll give it a different name, g of x, okay? It can be g of x equal x plus 1. What I transform here, I just add 1. I add 1 here, okay? Now what other thing I can do is, instead of adding 1, I can multiply with some number, say 2x. This is also I'm doing changing with the original parent function. Original parent function was f of x equal x, so I'm changing with the original function. So these are actually I'm doing the transformation, right? So I can have another function which can be g of x equals 1 by 3x. So these are the different transformations on the parent function. Now you can take a different parent function. For example, you have f of x equal x squared. Now again the transformation would be pretty much same. It can be f of x equal x plus 1 whole square, right? Now what are you changing here? You are changing in x, right? Okay, I'll not write it in this way, I'll write it in a different way though. I'll write in f of x plus 1. What I'm doing here, I'm changing in this x. Instead of this x value, I'm placing x plus 1 here. Okay. Yes, Chavez? Okay. So I am transforming this function. Instead of x, I am placing x plus 1. So you can name it like g of x. You say g of x equal x plus 1 whole square. So we added 1 in x. Now we'll see what's the consequences of adding anything in x or anything in y. What is there? What happens? What change from parent function to the transform function? What are the changing occurs? Okay. It can be like a function, the same function, parent function, and it can be transformed in this way, like f of x equals 2x plus any constant, say 3 square plus 4. Now this is also a transform function from the parent function. Yeah, it can be anything. X plus 1, it doesn't matter. You can place x plus 2, x plus 3, anything. Okay. The basic purpose is to explain you what changes we are doing in the original function. We can add anything. The purpose is just to explain what is the transform function. Okay. Okay. Now let us start with a function. Okay, so we'll take a function f of x equal x square. Okay, so it doesn't matter, it can be any other function as well. It is not required that this function would be used, f of x equal x square. It can be f of x equal x cube, f of x equal to, it can be a square root function, it can be an inverse function, any function. So I just take an example of a quadratic function, f of x equal x square. So this is the graph for this function. Okay, f of x equal x square, this is the graph, right? The basic graph. It is a parabola which is opening upward. Okay. Now we will perform some transformation on this parent function. Okay, on the graph of this parent function. So see, we have original parent function f of x equal x square, and the graph is, this is the graph of the parent function. Now see what transformations we're going to do. Now we are going to do some transformation, right? We can either move this parabola up, either left, either right. These are the transformation I'll show you. All right. So first of all, the first method is to move up or down. How to move the graph up or down? Okay. So how we can move it up or down, right, by adding a constant to the y value. All right. So let me give you an example here. Now this is a transform thing. Okay, if you can see that this was the original function that I show on above. Okay, now what's going on? This function is moving up by some units, right? This is the transform function at the top. Okay, this is the transform function, right? Okay, it is transformed by some units. Let's say this is a constant c. It can be any number, 1, 2, 3. Okay, so you can say what happened is g of x, original function was f of x equal x square. So the transform function is g of x equal x square plus c. Okay, as you know, you can just say f of x equal to y, like it is same as y equal x square. Okay, as I explained you before as well, that f of x is representing y. Okay, so what are you doing here? What I want to tell you that we are adding a constant in y. How? Right, see here, y plus c. I'm adding c in y, so I have to balance on the other side as well. So I do x square plus c as well. That's why I want to show here that what I done here is add some constant in y. Okay, I add a constant in y. Okay, and what are the consequences? If I add something in y, the graph is moving, is translating up by some units, c units. Let's say if it is 2 units here, so it 1 2, so it's moving 2 units up. Okay, and you have to write 2 over here as well then. Okay, so up till here, any confusion? Move on. Now this is in case we want to move the graph up. Okay, what if we want to move the same graph, the parabola, down? Okay, then in case of adding something, we will not going to add, right? We will use a negative value for c, right? Right now we are using a positive value for c. Instead of, it can be x square plus 2. So, but if we want to move this graph down, we have to add a negative value. It can be x square plus minus 2. You can add minus 2, which means you are moving the graph 2 units down. Okay, so we can say, so if we want to move the graph down, we will use negative value for c. All right, now you need to remember this. C, if c is greater than 0, all right, graph moves up. Okay, and remember that's for sure. You are adding c in y, okay, not in x. The other, if you add something in x, there will be different things you're gonna find out, right? Right now, what are you doing? You're adding something in y. If you add a constant which is greater than 0 in y, right, graph moves up. Okay, right? But on the other hand, if it is c is less than 0, right, graph moves down. Right? Now, so that's the first part of this transformation function, that we are explaining how to move the graph up or down. Okay, in the next time we will understand and we will learn how to shift the graph left side or the right side. Okay, left hand side or on the right hand side. Yes, so up till here, any confusion? Right. Yes, but if the number is greater than 0, graph moves up. Okay, if it's less than 0, graph moves down. Okay, yeah,